summary of the weather being experienced from Perth to Darwin, from Brisbane to Hobart. Back in the days before weather maps were made, people had little warning of the weather in store. In the past, more often than not, a fall in the barometer and dampness in the salt has meant rain. Does it mean rain this time? And if so, how much? These were questions which could not be answered until next day. Rapid communication over long distances has meant that the weather conditions from many different places can now be compared, studied together, and overall patterns recognized. Weather readings are taken at sea and all over the continent, and in the capital cities, the coded reports are received, correlated, and interpreted. Reports from about 600 stations are received each day.
Flinders Island, 3 p.m. Total cloud, 4/8. Wind, south-southwest, 15 knots. Air temperature, 53 degrees Fahrenheit. Dew point, 42 degrees Fahrenheit. Low cloud, large cumulus, 3/8 at 2,000 feet. Middle cloud, alto stratus. Rough sea, average heavy westerly swell. Rainfall, 23 points. Air pressure, 992.8 millibars, a rise of 2.7 millibars in the last 3 hours.
The Earth is completely surrounded by an ocean of air, which exerts an invisible pressure on the planet. The closer to the Earth you go, the greater the pressure becomes. A barometer used to measure the air pressure will give lower and lower readings the higher it goes, simply because there is a smaller quantity of air above to exert the pressure. In order that we may compare the air pressure readings taken in the mountains with those of the valleys, we speak of all readings in terms of sea level, and all barometers are adjusted to read as if all places were at sea level. Even when adjusted, the barometric readings still vary from place to place. The pressure change in 300 miles is likely to be no more than that experienced in moving up 300 feet in the vertical. Small though they are, these pressure differences and the patterns they make are all important in controlling the horizontal movement of air and the way in which the weather develops. In the charting of weather, the reported air pressure readings are marked on the map at the point where the observation was made. Places with the same air pressure readings are joined by a line. These lines of equal pressure are called isobars. As more localities are joined, the isobars form patterns of closed curves. If the curves indicate increasing pressure towards a region of highest pressure in the center, then the pattern is called a high-pressure system. If the increase is towards a line, then it is known as a ridge. If the pattern of isobars shows a decreasing pressure towards the center, then the pattern is called a low-pressure system. And corresponding to the ridge of the high, we have the trough. Winds blow around pressure systems, parallel to the isobars. In the southern hemisphere, clockwise about a low and anti-clockwise about a high. This results from the natural motion of air, from high pressures to low pressures, being deflected by the rotation of the Earth. Thus it is possible to predict the direction of the general wind, even in areas where no observations are made. Neither air pressures nor air pressure systems remain stationary, and the overall pattern is forever moving. The properties of air are influenced by the type of surface it is blown over. By examining a sequence of charts, we can tell the history of the air and can predict the weather it will bring when it arrives at a particular locality. Air coming from the dry center will itself be dry. Air having blown over the ocean will probably be moist, containing invisible water vapor which has evaporated from the surface of the sea. As the air reaches the coast, friction with the land slows it down and starts an updraft, which the seagulls use to gain lift. As this moist air lifts to greater altitudes where the pressure is much lower, it expands and as a result cools to the point where the water vapor condenses into minute droplets of water and becomes visible as cloud. A delight to the eye and, more practically, the possibility of rain on the earth below. Wind blowing over a mountain range also forces moist air to rise, expand, cool, and produce cloud. A cold front is another means of air lifting. A cold front is marked on the map, indicating the position where two masses of air with different properties are meeting. The line of the cold front indicates where a mass of cold, dense air drives wedge-like under a warmer, less dense mass. Lines of cloud in the rising warm air can therefore be expected along the face of the cold front, the ground position of which marks the advancing edge of the front itself. Sometimes it is the warm air which actively moves against and over a cold wedge. This is called a warm front. Once again, clouds can be expected where the warm air meets and rides over the cold layer. In all these situations, if the conditions of the air are suitable, the clouds will produce rain. A low-pressure system can also be the cause of clouds forming. Although winds in general blow parallel to the isobars, there is a tendency, especially near to the ground, for the air to spiral into the low-pressure center. This converging air is pushed up at the center, and again we have the familiar pattern of expansion, cooling, and cloud formation. The speed of wind is indicated by the spacing of the isobars. The closer they are together, the stronger the wind. On the 26th of March, 1966, a deep, low-pressure system over the Tasman Sea brought gales to the New South Wales coast. On the same day, a high-pressure system centered over Tasmania was bringing clear skies to the rest of the continent. The weather map is a summary of the weather information, plotted in terms of cloud formations, winds, air pressures, temperatures, and humidities. To the experienced eye, it gives indications of what is likely to develop. A simplified version is prepared for newspapers and television stations. By following the weather map, we can gain a better appreciation of the way in which our weather develops and a greater understanding of the background to the forecast.